can never hold back spring. You can be sure I will never stop believing. The blushing rose, it will climb. Spring ahead or fall behind. Winter dreams the same dream every time. Baby, you can never hold back spring. And even though you've lost your way, the world is dreaming of spring. So close your eyes, open your heart to the one who's dreaming of you. And you can hold back spring. Remember everything that spring can bring. Baby, you can never hold back spring. Baby, you can never hold back spring.
All right, I thought we'd finish up with what we were doing with our book demonstration here for classes, data processing, and ultimately what we're doing is searching and sorting for stuff here. But before we continue, what I wanted to do is I wanted to clean up the code that we have a little bit here first. For example, we've got a bunch of code to load up a bunch of books from a CSV file. By all rights, that should probably be in its own function because you're probably going to want to reuse that. Right? You can load up books from that file over there, load up books from that file over there, et cetera, et cetera. So I'm going to go ahead and put that, since it's a book thing, it's not a book, but it operates on books. I'm going to go ahead and put that into the book.py class, not class, but source file. And to do that, I'm just simply going to create a function, def load books, right? And I'm going to take in a file path, right? There we go, all right? Now remember, you need to do documentation, but if I don't want to do it right away, what's the best way to go about doing this is leave it as a to-do. Write documentation. Right? There we go. All right, so I just cut and pasted everything from the other file. What we're going to do is we're going to open up the book by book CSV file, but instead of hard coding that, I'm going to go ahead and use the variable that you've given me. And then I'll read all of the lines with one liner here, right? Now what I want to do is I want to make this a little bit more compact, right? For example, I don't need to separate these out into two different lines. If you want to strip all of the white space for line in lines, instead of going lines, you would say lines of 1 to whatever. And that will basically do both of those things in one line using a list comprehension. And let's make sure that the white space is correct as well. All right, there we go. Now I've got my lines. I need a book now, but there's a more compact way of doing that. Generally, what I like to do, I like to think in traditional, structured programming of do this, then do that, then do that. And so I do like writing this as a first draft, but then ultimately you can go ahead and use a compact, more compact list comprehension. Right, here we go. There. All I'm doing is taking everything in this for loop and I'm incorporated it into one list comprehension. Let's read it. For line in lines, that's the exact same for loop right there, right? I don't need to initialize it because it's a list comprehension. All I'm doing is taking it, each one and splitting it out, right there. Then I am splattering it, you said. Splattering it when I pass it into the constructor for a book. And instead of having to append it, I just simply make that my list comprehension value, right? So I'm able to take that 5 lines of code and winnow it down to only 1 line of code, right? And then don't forget to return books, right? What happens if you don't have that return statement? What does it return? None, right? And you'll sit there thinking, why is my stuff not loading? Why is my stuff not loading? Well, it's not loading because you forgot to return it. Now let's come back over here to demo and remove all of that stuff. Right? In fact, let's move all of that. And I need to import it. So I've already imported the book. So from book, import load books. Did I say load books or load book? Books. Okay, there we go. Good. Right. And to create my books, I'll simply call load books and pass in, what was it, bookdata.csv. There we go. And we already covered this. Remember that you have this built-in sort method here. And you can reverse it by passing in a named parameter there. But ultimately what I want to do is I want to sort my books. So I'll go ahead and get rid of that and clean that up. All right, let's run this to make sure I didn't break anything. Demo.py, there we go. The best book last time was The Hate You Give. The worst book was They'd Rather Be Right, 3.05. Still working, okay? The oldest book was The Odyssey by Homer, negative 700 BCE. And then Harold by Stephen Wright in 2023. I don't have any 2024 books here. Right. Okay, so everything still works. What else do we want to do as far as data processing? Let's find all the books by Terry Pratchett. Okay. All right. Well, there is a linear search method. It's books.index, right? And you could do the index of, say, a given book. So for example, did I delete it? Yeah, I deleted it, unfortunately. So let's go ahead and create a book here. B is equal to, or let's call it what it is. It's a key. Book by, I don't know. Let's find a book by Terry Pratchett. Pratchett. There we go. There. All right. So if you want to find that book, you can do something like this. Johnny and the Bomb. There we go. Pratchett, comma, Terry. All of those are strings. That's a number, that's a number, that's a number. There we go. So I can create my key, which is a book, and then I can ask the index of that thing, right? And I need to retrieve that, so index is equal to that. And let's print it out. Print formatted, right? Found key at index. So we should find that somewhere in there, right? Oops, nope. Johnny and the Bomb is not in the list. Oh, okay. It should be. Did we treat these as integers? I forget. Anybody? Let's take a look at the book class. So I'm treating the first one as, okay, a string, and then float and int. So I need to treat them all the same. This has to be a string right here. And I should be able to find it now. Nope. Darn it. It's not in the list.
ISBN is a string.
Oh, ISBN is a string too. Thank you. Only the last two are numbers. Okay. So there we go. Found Johnny and the Bomb by Terry Pratchett, 1996 at index 49. Right? That is if it's unsorted, right? The index is basically a linear search method. ... However, what did I have to do to my key? I had to have everything specified, right? And that's so if you have everything specified, why are you going out searching for it to begin with? I already have everything, okay? So you might think that you can do something like this. Create a dummy key, right? Where you've got key is equal to book, none, but Pratchett and Terry, got to spell it correctly. There we go. Terry, and then none and none and none. That's a typical dummy key because I only want to search based on the author's first name and the last name. This will get me a match, or I want this to give me a match. Unfortunately, it's not going to work because there's no such thing as a book with a none title, right? In fact, you can't even do a float value here. You could do 0 and 0, I suppose, and get those correct, but it's not going to match, right? Okay. Ideas. So you're going to have to roll your own linear search algorithm. But remember, do we really want a linear search algorithm? Now, what's better than linear search? Binary search. Binary search. Question mark? Question mark? There is no binary search in Python. You can write one if you want to, right? You can write one, get it wrong, debug it. It'll work for 90% of the things that you do. Get it wrong again, debug it again, etc. You can copy it from somebody else and hope that they didn't get it wrong or whatever. Why is there no built-in binary search? Clearly, there's a built-in linear search that works on the entire thing. But why is there no binary search? It's because Python thinks you got enough already. You've got something even better, right? Dictionaries are even better. So saith Python, right? Whether or not you agree or disagree, whatever. But at the same time, Python is kind of right because lists are not arrays. Technically speaking, under the hood, they are hash maps. They are hash tables. And as a consequence, they are not random access. When you've got an array and you're doing a linear search of an array or a list, which has an array list, has an array under the hood, right? You can jump to the middle element and then determine, do I need to go left or do I need to go right? That doesn't make sense when you don't have regular old arrays and random access. So binary search doesn't make sense for Python because you don't have these things. Instead, what they want you to use are dictionaries. So as a first step, let's go ahead and reformat our data. All right? Let's collect all books by authors. In other words, what I want is I want an author, and I want that to map to a list of their books that they've written. Okay? That would be really, really helpful, right? Because now I don't need to search with a dummy key. All I need is Terry and Pratchett, and there's my key, right? And it that Terry and Pratchett maps to these 5 books that he's written that are in my collection, right? And then I can do that for any author whatsoever. So my first step is to resolve this key here. Ideas on that. So if you're thinking in an object-oriented programming manner, what would you do? Here's my design of a book, which has an ID, a title, last name, first name, ISBN, rating, year, etc. But really think about these two things right here. Is that really a book? Or is that a book thing? Right? Not really, because it's an author, it's a person, right? So what if I added down here another class? Actually, I need to do it above. Order matters, right? Class person, right? And they have a first name and a last name. So represents a person, author for the book class. There we go. Right? Dot, dot, dot. This is how I would do it if I were thinking in an object-oriented programming manner. Right? Copy that, self, and now I've got the last name and the first name. Right? And I would say, self.first is equal to first, self.last is equal. I'm going to create oh, come on. No. It's mine. Whoa, okay, there. My entire computer froze up there, not just my browser. I wonder what that'll look like on mine. That'll be cool. Right. Self.author is equal to person and last first. What's the order? Last first. Last first. Right. Instead of these two things right here. Right. That's the way that I would do it if I were doing this in an object-oriented programming manner. And you can do that. Right. Let's go ahead and see what it would look like. Right. Well, I don't have any authors here. Right. So I need to go through and create all the authors. So step 1, go through the books, and create a set of authors. Why do I want a set and not a list? No repeats. All right, we can do that as an exercise. So for book, be in books. Right? What I'm going to do is I'm going to create an author, right? Person of B dot last name, B dot first name. Actually, no, I don't need to now, right? Because I'm doing that in the constructor, right? If I do this in the constructor, I can just get the author here, right? So author, and I can just add it to the set. So let's create a set. Authors is equal to a set, and then authors dot append or add. It can't be append because that implies that it's at the end. So I think it's add author, b dot author. Oh no, is it?
Thought it was add.
I think it's add, but no, I'm looking at the live stream here. Yeah, we're good. All right. All right, so let's find out if this works. prettyprint.pprint authors. Right. And I also need to bring it in because now it's in the book class, or it's in the book source code, but I don't have person in there. There we go. All right, and let's find out if that worked. Uh-oh. Oh, and not last. Where are you complaining
I
about?
think it's to intro.
Printing, thank you. So we can get rid of book class. Where's my print method? There it is. And not the last first, but self dot author. There we go. And author. That should work, but actually it won't because it doesn't have a toString method here. So we can save that. We can take care of that. Cut and paste that stuff. And self dot last comma self dot first, and then that's all I want. There we go. There we go. All right, now it should work. There we go. So you can go through and verify that in fact, actually no, let's go ahead and look. I see Terry Pratchett right there. Do you see him anywhere else? Actually, I didn't see him. I saw Ian Fleming and Ian Fleming. So we're getting duplicates. Why is that? So how does a set determine, is Ian Fleming in there already? How do you determine if a book is in there already?
Compare them.
You compare them, and how did we do comparisons in the book class? EQ and LT, right? So yet again, we need to cut and paste that stuff too, right? All right, how do you want to order a person? We need to use, actually, I think I already did it, didn't I? Last name, first name, and then we don't need an ISBN. Last name, first name, and we don't need an ISBN. There we go. And return that, but it is strictly less than. There we go. All right. So it'll go last name. If the last names are the same, because we have like Herbert, Brian, and Herbert, Frank, right? Then it'll go to the first name to break ties that way. All right. Now let's see if that worked. All right, clear this and Python. Oh no. Unhashable. Oh, thank you. Actually, yeah, that'll do it for me, won't it? Hopefully this will do it for me. Let's find out. Or do I have to do more work? No, it's unhashable. So Python hash function. So a set uses a hash table, and the hash method needs to be implemented for custom types. Obviously, it's already in there for all the built-in types, strings, integers, whatever. But to put it into a class, it's the hash, come on, and there we go. There's what it looks like. And I will simply just grab that and use it over here. We didn't have to do that for the book class because we never actually used it in a set or anything. But we have a custom object here, so we need, and I'm just going to steal the exact same thing as above here, right? That tuple right there. And now this should work. Right? Same thing happens in Python, by the way. Python, you have an equals method and a hash code method. You can auto-generate those using Eclipse. Here, we're just there's not an easy way to auto-generate those. But not only that, but look, they're in nice order there. Right, cool. All right. Everybody from Adams, Douglas, all the way down to Yevgeny Semyentin. I don't know how do you pronounce that. Right. But I only see, yeah, Pratchett in there once now. We're good. All right, back to this. Okay. Is there a more compact Pythonic way of doing this? Should I have to roll through every single time and add it, and letting the set take care of it for me if it doesn't add it? List comprehensions. Right? So authors is equal to all b.author for b in books. Right? Got it done in one. Except is that a set? Nope. So how can I make that into a set? By calling set. Right? Got it done in one line. Exact same as before. Now that I've got all the authors, now I can go ahead and iterate through and create a author to books map. ... So author books. There's my initial map. It's an empty map. Now for each author, for author or for person A in authors, right? Then I need to go through and get all their books. So for B in books, right? I've got a loop within a loop, right? Now, generally you don't want to do that, right? What if I were doing my assignment with a loop within a loop? And I had 1 million patient data records. 1 million patient data records on this file over here, 1 million patient data records on this file over here. For each one, go through 1 million records to try to find that other guy. 1 million, 2 million, 3 million, 4 million, ... 1 million times 1 million is going to be, we call them trillions. 1 trillion operations is not at all efficient. Right? So we're going to rethink this, but we can do it traditionally like this. For example, let's say author books sub A dot add, I guess, B, right? So walk me through that. Author books, I am using as an index an author, a class, right? A person instance. And then I'm going to add them to B. In other words, I'm going to treat this thing that I get out of this as a set, set.add. Let's try it. It's going to fail because is A in this map initially? No, not yet. So what I need to do is if A in is in author books, or in other words, if we have seen the author before, it has a set. Just add the book to it. ... Right? So I can do this. Else, and then I need my my semicolon there. I don't have a set yet. So what I need to do is I need to say that author books of A is equal to a new set. Then I can add it. There. And this should work just peachy, I think. Hopefully. Right. Okay. Unhashable type book. Fine. Now that I'm using a hash value, I do need to put it into the book class. There we go. And I don't know. How would you hash this? Usually with an ID. So an ID or an ISBN. Which one do you want to do? They're both guaranteed to be unique. Except that remember, some of our records don't have an ISBN. So we can't hash something that doesn't exist. So hash self.id. There. Lots of boilerplate stuff, but in the end it works. Right? So let's pretty print that. .pprint. Author books. There we go. Ah, nice. All right. That's definitely wrong, though, right? All right, if we can find an author here. Where's an author? Here we go. Apparently he wrote everything? No, that's definitely not right. So let's figure that out. All right. So if A is an author, then we simply just need to get it and add books. Otherwise, we need to set its value and then add it. Actually, I don't see a problem here. Oh, we're doing it for all of these. We're never checking the author, are we? Right? Do you see the problem? I'm adding them regardless of whether or not this author wrote that book. All right? So for B and B, let's add another if condition here. If A is equal to B dot author, then we do all this stuff. There. That looks a lot better. Otherwise, we kind of ignore it. That looks a lot more manageable now. H.G. Wells wrote, in fact, these 3 books. The War of the Worlds, The Invisible Man, Island of Dr. Moreau. Stephen Wright, as far as I know, he's only written that 1 book. He's not usually an author, he's a stand-up comedian. There's David Sedaris with 4 books. Those are all his, definitely. Where's Terry Pratchett now? There we go. There's Terry with those 5 books. Now that I've got this map, how can I get all the Terry Pratchett books? Pratchett books is equal to author books of, I need to create an author, so Pratchett is equal to person, Pratchett, and Terry. There. And I'll get Pratchett, and then I'll print them out. Spell it correctly everywhere, though. Pratchett, pprint.pprint, Pratchett books. Okay. And there. Monstrous Regiment, Only You Can Save Mankind, Johnny and the Dead, Johnny and the Bomb, Witch's Vacuum, etc. That is much, much easier because now I can do a whole bunch of things. For example, like the video game demonstration we gave, if you have this kind of mapping, you can go through and create a report. How many books were written by each author, right? You can have the reverse. Here's a book and here's its author, et cetera, et cetera. Does that look like Python to you, though? Not to me, right? So how could we change this so that we're doing it in a more Pythonic view, author, books, or in a more Pythonic way, right? I want a key value pair mapping, right? All right. What's my key going to be? The author, for author, in author, authors. Remember that I have that as a set up there already, authors, just reuse it, right? What about my values? It's going to be a set, right? And that'll get me halfway there. That'll get me all the authors mapping to an empty set, okay? So how do I get this set right here? Books of author, right? All right. I need another list comprehension, right? I need a list right here, or a set of a list. There we go. Now, how do I get all of the books by this particular author right here? All the books B for B in books if B.author is equal to author. Right, there we go. White space matters, but I'll keep it long like that. Let's see if that gives us the same. There we go. I still get monstrous regiment ... down to the witch's vacuum cleaner. So which one is more Pythonic? Definitely this one, right? You don't have so many if-else-if conditions. You don't have a two nested for loops, right? Now, Python is going to do things in the most efficient way that it thinks is the most efficient way, right? It will not do a nested for loop, right? It will, that 1 million times 1 million thing, you will probably not have that if you use some sort of a comprehension like this, right? It'll take care of all that for you. Cool. Now I've got all the Pratchett books. Here's an alternative. Less OOP, more Python, right? More Pythonic, right? You can use tuples as keys, ... So for example, suppose that I did go ahead and create this person class, but ultimately it was a lot of work. I had to create a constructor. I had to create string methods, a representation method. I had to use equals and less than, and then you had to remind me to use a total ordering. And then I was going to use it in a set, so I had to use hash, lots of boilerplate stuff. That's the object-oriented programming way to go. Right? And normally I would do it that way. But you can also use tuples as keys. Right? So let's go ahead and do that. Authors is equal to, and I'll do a list comprehension here, right? All, let's say, A dot last, B dot, or A dot first, for A, no, I want B dot author. B dot author, dot last, B dot author, dot first, for B in books. Right? And let's change that into a set. Because I only want distinct values, no duplicates. Pprint dot pprint authors. Right? There. Now I do not have a list or a set of authors anymore. I have a set of tuples, the last name, comma, first name. But that's what an author is, right? That's what a person is, right? So why get fancy with a class when you can do everything with tuples? And now you can use that, each tuple, as a key. So for example, author books, right? Let me go ahead and bring that down here and do this again. For B in B, if B.author is equal to author, if, let's say, not author, but author, so 0 is the last name, is equal to B.author.last, and, oops, all lowercase and, right? And author of 1 is equal to B.author of first. It's a tuple, so the first one is at index 0, the second one is at index 1. Right? For not for authors and authors, but for, yeah, for author and authors. Right? And let's pretty print that out. Author of books. See what it looks like. Oops. Oh no. Okay, there we go. That's what I wanted. I did not lose my terminal. So do you see the difference? H.G. Wells as a person is no longer the key. Instead, it's this tuple, right? And you've got these over here, right? It's very, very useful if you want to do, say, pairs, right? So for I in range of n, let me go ahead and go with n is equal to 10 here. How would you go over every pair in, say, like a matrix or something, right? For I in range of n, sorry, I already used I, j. I can do something like print f I, comma, j, right? I can do all pairs like this, Python, and you'll get something that looks like this, right? If you want to do a two-dimensional matrix, like you're doing in your assignment for that the rainfall or whatever, that utility function there, you would do something like this to iterate over all of those pairs: 0, 0, 0, 1, 0, 2, etc. You would use a two-dimensional array. It's not really a two-dimensional array; it's a list of lists. Or what you could do is treat that as a tuple. X is equal to I, comma, j, right? And let's add that to a list. So values, or let's say pairs, is equal to whatever. And let's go ahead and go pairs dot append x. Pretty print that. Pairs. Oh, yeah, come on. There we go. There, 9, 9, 9, 8, etc., right? You can use tuples, triples, quadruples as key values in a map. For example, I can make each one of these map to their sum. So for example, for x and y in pairs, I can say that my map of x and y is going to map to x times y. And I need to create my map is equal to whatever. Let's print that out. And all it's going to do is print out, x, y to x times y, my map. Once again, let's take a look at what that looks like. There we go. So 9 comma 2 maps to 18, their multiplication. 9 times 9 maps to 81, a basic multiplication table, right? Nice. Is there a more Pythonic way of doing something like that? Just more practice here, right? Pair mapping is equal to a mapping, right? What's my key? X comma Y, right? And then I will map to X times Y for X in range of N and Y in range of N. There. And it's the exact same map here, but it's way more compact. Right? You don't have to go over it twice. You don't, oops. What is it, comma? Oh, say what? Is it and or is it comma? Let's try that. No, I think, yeah, you're right. It's and. Right. No, it's not. Come on. Bool object is not iterable. X and Y, X in range. Come on, what is it? Oh, I know. I need another 4. For X in range, for Y in range. That's what. There we go. So yes, there is an implicit and here, but I don't think that you can put that there. That is not an and. So if you need a loop, you need to have 4 and then 4, and that will give you the nested for loop there. Right? And exact same as before. 9 times 7 is 63. Lots of little tricks like this all over the place. Right? One mapping can replace, 10 lines of code here. Right? Way more compact. Which one is more readable, by the way? At least in this particular case. Right? I, J, and range. Okay, so it's iterating over both of those. Then you're creating a tuple, and you're adding it to pairs. And then you're iterating over all pairs and pairs. And then you're putting in that map. Okay, great. Versus this, that's all in one line. It's kind of a set builder notation. At least in this particular case, I would agree with the Pythoners that this is the better way of doing it. Because it's all just right there. It is what it is. It is what it says it is. Right? It's a declarative programming style where you're not saying this is how it's done. Right? You're saying this is what it is. Python, you take care of how it's done. Right? It's a little bit more abstract way of thinking about it. That really took me to the end of everything that I generally wanted to show for Python. So what more could we do with the books or with this stuff or what? Anybody? All right. Then my go-to is going to be, did anybody do Advent of Code over the break? No? No? Come on. Let's do one. I'm not logged in here, so I don't have an answer. Newly improved, so we'll ignore the story here. Calibration document consists of lines of text. Each line originally contained a specific calibration value that the algorithm need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. So for example, if I have 1 ABC2, then that would be 1 and 2. The first digit, 1, and then the last digit, 2. For this one, it would be 38. For this one, it would be 1, but 2 is not the last. Instead, 5 is the last, so that gives us 15. And then we add the last one, which is 7. But in this case, there's only one 7, so it's the first and the last. All right? I like this exercise. What we're going to do is then we're going to sum those up, sum all those values up. All right. Let me back up the demo so that I don't lose it. Copy demo to class demo.py. And let's get rid of all of this. I want pretty printing now. All right. There's my input. Input is equal to each one of those. I could put them into a string, comma, and then this will be a list. All right. Is there a better way of doing this? I could put it all in one big giant string. There we go. Now, if I want to split that out into each line, what would I do? is equal to input dot. How do I split a string out based on end-line characters? Split end-line characters. In end-line characters. There we go. Let's pretty print that to make sure that I've got it. Input. There we go. Oh, what's wrong? You have to be on your own line, and you have to be there. There we go. All right. Oh, I've got the one too many. There we go. All right, now I've got my input. So for each one, I just need to find the first digit and the last digit, treat those as a number, and then keep a running total for that. Let's do it in a traditional way, basic for loop. For S in input, right? How do I find the first digit? How do I find the last digit? First is equal to, I don't know. This is a string. How do I iterate over the characters in a string? For C in S. Right? For character in this string. Right? Now I can set the first if C is a digit, right? Then I'll set first. First is equal to C. I'm just outlining this, right? Otherwise, I want to go backwards, right? I'm already programming myself into a corner here, right? Once I've got the first C, what should I do? I should break, and you do have the break keyword here, right? For C in S, but reversed. If C is a digit, then last is equal to C, and then break. Right? There's my outline. So Python, how do I do this in reversed? Let's start, I don't know off the top of my head. Python, reverse a string. I think it's just reversed, or yeah, it's reversed. Show me an example. I don't need an entire article. There we go. Reversed. So I can reverse this. Reversed S. Right? How do I determine if something is a digit? That's another Google search, or better yet, DuckDuckGo search. Python is a character, a number. There we go. Is digit? There, is digit. So, iteratively translating these things. What is digit? Okay, so is digit. And it is a function. There we go. And if C is digit, then we get that. All right. Now I've got the first and the last. Okay. What next? Number is equal to first plus last. That'll give me a concatenation, but will it treat it like an integer so I can add it up? Nope. There we go. And sum total plus equals num. Right. And print it out. Print f total. What was the total? What should have been the total? 142, looks like. So it should be 12, 38, 15, 77, right? We can do a little bit of debugging too. Print f num. Right. So we should get, again, 12, oops, total is equal to 0. There we go. 12, 38, 15, 72, and 142 to me. Looks like it to me. Right. But is that really the Pythonic way? No. Ideas? List comprehensions? No? Right. I think that there is if we have strings, Python string first. Actually, what if I were to winnow them down? For example, what if I were to winnow this down and remove everything that was not a number, right? Then would it be easy? Yeah, the first digit, the last digit, right? All right, so how could I do that? Do we remember regular expressions. All right. Python replace or remove. Remove regular expression string. Actually, replace will probably work. You just replace it with nothing, right? So, substring, punctuation. I'm going to get the book on this. So I do want Python string replace. Spelled correctly though. W3 schools is terrible. Is this going to give me regular expression? Nope. Fine. Python string regular expression replace. Didn't we do this? RE, wasn't it RE? RE. And not substring, but is there a replace?
Is sub a substitution?
Oh, is it? I thought it was substring. Okay, yeah. It's in our notes somewhere. Find RE dot. RE split, RE split. Okay, we did it for splits. All right, fine. All right, so let's massage the input first. Input is equal to all RE dot sub. I will sub anything that looks like a lowercase a through z, uppercase a through z with nothing. Right. And I want one or more of them. All right, for, oh, and I guess I need the S, for S in input. There. I need to split it first. And let's go ahead and get rid of the rest of this for now. There we go. And let's see if that worked. Nope. Oh, import RE. Come on. There we go. Oh, I replaced everything. All right, what is sub? Do you remember what it looks like? Substring RA with banana. So there's the regular Python RE sub. Sub. So there's the pattern, there's the replacement, and then there's the string. So I've got them reversed. So I want the replacement be nothing, and then the string. There we go. That's what I want. Pattern, replacement, string. It's just, that's backwards, right? So do you see that it worked? I got rid of ABC. I got rid of PQR. I retained only 38. I retained only 1, 2, 3, 4, 5, et cetera, et cetera. And now what we can do is we can go through and only get the first and the last. So input now is going to be for S in input. Let's see, it's going to be S dot first. I think you can do this. S of 0 plus S of length of S minus 1.
You just do -1.
Oh, good. Using that noggin there. Remember that Python, you can use arbitrary, not arbitrary, but negative values, and what will happen? It'll wrap around to the beginning. And there. Now I'm getting 12, 38, 15, and 77. Now I can surround that with an int. And I will get 12, 38, 15, 77 as numbers. And then as my final solution here, I'll just say sum of input. That's a built-in function that I can then print the total. 142. 142, right? Okay, good. All right. So there's the Pythonic way of doing it. It'd be even more Pythonic if I took those 3 lines and then squished them down into a one-liner, all one list comprehension. Right? And then didn't even store that off, just put it into sum here. Right? Again, the power of regular expressions. Not that you'll have to use them in your assignment, but it is something that should be in the back of your mind always because it can save you a lot. All right? Stripping things out, finding fuzzy searches and stuff like that. When we come back on Wednesday, let's move on to Java, and let's actually not this exercise, but let's think about how we would do this in Java instead. And so I'll give you a really quick demo on the tools that you already have in Eclipse to auto-generate much of this stuff that I had to type out.